Dit bestaan uit 2 fluoratome. So we've got one and another one. How many valence electrons does each of them have? 7. So ons gaan 1, 2, 3, 4, 5, 6, 7 en 1, 2, 3, 4, 5, 6, 7. Ek doen dit net met kruisies dat julle kan sien wat ons nou gaan doen. So I do them with a one open orbital pointing towards one another. You didn't have to do it like that, as long as you drew something like this for an answer. You didn't have to do it with crosses. I just do it with crosses that you see that the one is from the one atom and the other one is from the other atom. Okay, en nou as jy na elkeen van jou atome gaan kyk, het hulle, ons noem dit die octet rule. So the octet rule says 8 electrons around an atom. Okay, so sien julle elkeen van hulle het 8 elektrone. Die uitsonderings op die octet rule gaan ons nou maar oor praat, maar die twee waarvan julle klaar weet is waterstof en helium. So hydrogen and helium doesn't follow the octet rule because they don't have enough orbitals to put 8 electrons in there. Okay, goed. So dan by 1.3, nee man. 1.3 het ons gedoen PCl3, so you say this one. How many valence electrons does phosphor have? 5. And then you have the chlorine, and that one has 1, 2, 3, 4, 5, 6, 7. Don't fill it like I did. 1, 2, 3, 4, 5, 6, 7. And this one also has 7 valence electrons. Okay, daai ene lê nou 'n bietjie ver. But if we look at each of our atoms individually, you should see that their orbitals are completely filled. So hulle is stabiel, so hulle is gelukkig. Cool. By 1.4, ek gaan sommer net die antwoord teken. As een van julle 'n vraag het daaroor, sê maar net. So 1 electron from each hydrogen, and then carbon, I told you guys, remember, we don't fill carbon 1, 2, 3, 4. We fill it 1 in each. And carbon is weird. Okay, so hy het 1 waterstof by elke een van sy bindingspunte. Everyone happy with that? Good. And then 1.9.
Grade 12E3 to room 1, please. Grade 12E3 to room 1.
So, en dan as ons hom daar inskuif, dan lyk hy net so. Of met kolletjies.
What if we put it on top?
Doesn't matter.
So it can be anywhere, each side.
Any side. So you could do this, or this, or this. Doesn't matter. Okay, en die laaste ene is nie hierdie jaar nou meer op julle so groot van toepassing nie. But if you were still doing the different structures of our molecules, which I told you guys we are leaving out, you would have to know that this is called a lone pair of electrons. So instead of having a single bond there, it has 2 electrons alone in an orbital. Okay, en dit beïnvloed die vorm van my atoom. So this one also has a lone pair. Dalk as ons 'n bietjie ekstra tyd het, sal ek vir julle net vir interessantheid wys hoe dit lyk. And then it has a H on each of its bonding sites. Okay, en onthou, waterstof volg nie die octet rule nie. It doesn't follow the octet rule because it doesn't have enough orbitals. So those hydrogens, even though they only have 2 electrons, they are satisfied. Hulle het hulle 2, hulle is happy. Terwyl stikstof soek 8 om hom. So if you go and count the electrons around nitrogen, it has 8. Okay, onthou nou, ons is nog steeds heeltyd besig met kovalente binding. So there's no transfer of electrons. It's not an electron carried to another atom that forms 2 ions. Dit is net 'n gedeelde orbital. Hulle letterlik oorvleuel en dan beweeg daai elektrone in al twee die atome se orbitale en dit is hoe 'n binding vorm. So do you agree that in all of these that you guys did, we have single bonds forming because 2 electrons equals 1 single bond, single bond, single bond, single bond, single bond, selfde hier, selfde hier. So, as ons sy voorstelling moet gaan teken, hierdie ene byvoorbeeld, sal hy so lyk, en hy daai 2 daarbo, hierdie ene sal net wees HF, en hierdie ene sal so lyk. Met 'n kroontjie op. Okay, but you get the idea. So enkelbindings. Sien julle, ek maak net een streepie tussen die atome, enkelbindings. Now we're moving on to double bonds or more than one bond. In your books, I am on page 18. No, first page 17. Okay, I'll talk to you about D at the top of page 17 now. We're going to do those examples. But first, I want you to highlight in your books where it says more complex molecules can be illustrated using the Lewis notation. Dis so halfpad in die bladsy onder daai tabelletjie. Dan sê hulle vir jou die octet-reël is belangrik, so highlight dit vir jouself. En hulle sê ook vir jou vir al elemente van periode 2 volg altyd die octet-reël. Okay, so remember period 2 it starts with lithium, that one, and then goes straight through to neon. So especially when we are working with those, ander ook, maar veral elemente uit periode 2 volg altyd die octet-reël. Now, right at the bottom, it says quick facts. You need to know that beryllium is happy with only 4 electrons in its valence energy level. Met ander woorde, beryllium, as hy net 4 elektrone het, is hy gelukkig daarmee. Okay, julle moet dit weet, want julle gaan teken met beryllium in, en dan hoef jy nie vir hom 8 elektrone te soek nie, hy's happy met net 4. Dis dieselfde as wat julle moet weet, waterstof is happy met net 2. Okay? And then the other one is boron is happy with only 6. Om sommer net vir julle 'n baie leuke verduideliking daarvan te gee, dit gaan maar oor hulle nucleus, hulle kern, is nie groot genoeg, hy het nie genoeg protone om die ander te support nie, so they don't mind only having one of them 4 and the other one 6. Maar julle hoef nie te weet hoekom dit so is nie, maar julle moet weet dat dit so is. En ons gaan voorbeelde doen van hulle, dat julle dit oefen. Okay, now I'm back to the top of page 17 where they say, if we are working for instance with O2, stem julle saam, dis 'n kovalente binding? Why will that be a covalent bond? Twee nie metale. Okay, in other words, we are looking for an overlap of orbitals. Now, I can tell you, before we even start, that when we deplete O2, it looks like that. In other words, you see that it has a double bond there. But it is impossible for you to go and study all of those. I can also tell you that nitrogen looks like this. N2 lyk so. Maar julle verstaan, dit is onmoontlik om hulle almal te gaan leer. Julle kan nie gaan leer dat al die verskillende molekules het hierdie enkelbindings en hierdie dubbelbindings nie. It is too much. Okay. So ons gebruik die Lewis struktuur om vir ons te sê, werk ons nou met enkel of met dubbelbindings. Okay. So what we do for that is, you start off by saying 1, 2, 3, 4, 5, 6. Just 6, sorry. And this one also, no. 1, 2, 3, 4, 5, 6. Okay. Hierdie is eintlik relatief maklik om te sien. Do you see that it has 2 vacant spots for electrons on both of our oxygens? So instead of finding something else to join in, they just say, okay, let's bend 2 of our orbitals to overlap with one another. Okay, so hy gaan letterlik 1 orbitaal en nog 'n orbitaal van die een suurstof vat, 1 orbitaal en nog 'n orbitaal van die ander suurstof vat, en hulle gaan buig na mekaar toe en overlap. So it will not only have 1 orbital sharing 2 electrons, it will have 2 orbitals sharing 2 electrons, and that is why it forms a double bond. Nou, julle moet leer hoe om, ek wil amper sê, dit uit te werk. So, wat hulle sê die maklikste manier is om dit te doen, is begin deur te sê, single bond. Single bond between those. And then you add the rest of them. So then you go, remember I want 8 around each. Okay. Ons gaan nou op die volgende bladsy is al uitgeskryfde voorbeelde. But now if we go and count the total number of valence electrons, you have 2, 4, 6 plus 6. So we have 12 electrons available in total. So ons het net 12 elektrone beskikbaar in totaal. En as jy hier gaan tel, het jy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So because we have too many electrons there, we then say, obviously it can't have all of those pairs, so they have to move in. And they do that. Okay, so now if you go and look at this oxygen. Kyk tot waar ek gehighlight het. Tel gou hoeveel elektrone het hy om hom. 2, 4, 6, 8. Do you agree? And if I go and look at this oxygen. Do you agree? 2, 4, 6, 8. Okay? They basically just bend more towards one another. Okay, so nou as ons gaan kyk, is daar 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the amount of electrons we had to start with. So jy het nie extra elektrone daar gaan indruk nie. Al jou atome is happy, hulle het hulle 8 elektrone, check. And now if we deplete this, we say it's O, double bond O, because they have 2 orbitals that shares electrons. How many electrons are they sharing in total? 4, né? Onthou dis 2 per orbital.